I have DesignBuilder open here already. The site is set to London Gatwick, and if you want to use a different location or different weather files, you can add a new template here, drop your weather file into a special folder and then load it. For us, Gatwick is okay. Now let's start a new building. This brings up a dialog to let you set the default data. As you can see, the current use of this room is a generic office. If you click on that, you can check the details inside, and there are a lot of details in there indeed. The DesignBuilder template systems contains a lot of data. Now the question is, do you really need to know what they are? Well, yes, unfortunately. It is quite essential to know exactly what have gone into the model before you can even tell whether the output is meaningful or not. So if you have forgotten what they are, it's probably time to revisit the manuals and the tutorials. I will leave all of them to default at the moment, except I want to get rid of the window. Okay, change it to no glazing, and that's it. Right, now we are ready to add our shoebox. So I will change the height to 3 meters, change the drawing method to rectangle. And remember, this is a single zone, so it can't be too big. Let's say 4 by 6 will be fine. So you type 4 space and 6 in there and press enter. There we go. Have our little box here. The next thing I need to do is change the surface adjacency, because let's assume this is a mid-floor office in a block. So we shall change all the surfaces to adiabatic, which means the heat transfer between the neighboring zones is ignored. Let's go to construction, and unfortunately to change adjacency you have to go down to the wall level. So if you expand that and pick each wall, you will see an option called adjacency. By default, it's auto, which means DesignBuilder determines what the other side of the wall is automatically. I'll change it to adiabatic, and I do that for all of them. Except the last one, I will leave it as auto, which will be determined as an external wall. We can have a look which surface it is. So this is a south-facing wall of that model. That's exactly what I want. Now I can add a window to it. The way I want to do it is to use the opening template to specify window to wall ratio. So I still have that wall selected. I go to opening, and at the moment all the surfaces has no window. Now I change that to a appropriate window to wall ratio value that I want. It doesn't really matter which. Let's say 20% with a preferred height. And now if you look at the building, and you see a window on one wall, and if you go to the zoom level, and you can see all other surfaces are marked as adiabatic except this one, the front wall. Okay. So now we are ready to run some simulations, but when you are doing it, you must check all the settings available here to make sure that you have got the correct information in them. Especially the activities. This is where you define the internal conditions such as set points, humidity control if you want it, lighting settings, or ventilation requirement, or any internal gains you have in the space. Note that activities, or the use of this zone, is what we call the boundary conditions. They are normally decided for you by someone else, for example, the client. The other parts, like the construction, openings, lighting, HVAC, etc., are design parameters for which you had freedom to choose. There are exceptions, of course. For example, if you have a large building and try to arrange the functions of different spaces, then the use of each space can become a design variable. Now we're talking about using multiple shoeboxes to do analysis and switch functions between them. Nevertheless, the number of shoeboxes or number of use of spaces are likely to be fixed, hence they can still be considered as boundary conditions. In your particular situation, however, it is a very special case, because in most of your projects, you are the client, the architect, and engineer all at once. So, in which case, your project will allow you to choose whatever functional spaces you wish to have. If you can choose the function of each space based on its potential environmental performance, then the use of spaces are truly a design variable. I will leave everything to the defaults for now. We can run some simulations. Let's do heating design first, because it is the simplest. So go to heating design and update data. I'll leave everything as default as well, so click OK or start to run simulation. It should be fairly quick. There we go. We got some results back already. Now, my next question is, how do you rate these results? Well, you see the big red bar is the total heating capacity. And those are actually the elements contributing to the heating demand. If you look at the breakdown, it's very clear that external ventilation and infiltration contribute the most to the heating demand, whereas the heat loss through the window and the wall are fairly minimal. This will tell you which area you need to tackle first.